Hello, guys. I'm going to start homework 29:30 due this weekend. I'm just going to share the slides right now. So this is the first problem. Focus on concepts. Question 02. Let me make this bigger. Photons are generated by a microwave oven in the kitchen and by an X-ray machine at the dentist's office. Which type of photon has the greater frequency, the greater energy, and the greater wavelength? So you know wavelength and frequency are inversely proportional. If you have a high frequency, you have a low wavelength. If you have a low frequency, you have a large wavelength. Okay. So the correct answer here is B. X-ray has high frequency, so it has greater energy, but microwave has the greater wavelength. Okay. Because X-ray we have lower wavelength. So B is the correct answer for this. Okay. Focus on concept question 03 says a 90-watt red light bulb and a 60-watt green light bulb are turned on. Which bulb emits photons with the greater energy from the color of light? We know ROIC, beef, red, orange, yellow, green, blue, indigo, violet. Is that okay? ROIC, beef, we call it. So the green bulb, the green photon has a greater energy than the red photon. That's the correct answer. So the next question is focus on concept question 05. It says a laser emits a beam of light whose photons all have the same frequency. When the beam strikes the surface of a metal, photoelectrons are ejected from the surface. What happens if the laser emits twice the number of photons per second? So we'll have all these options, but the correct one is B and C. That is option number D. Both B and C can happen in the sense that the photoelectrons are ejected from the surface with the same energy, it doesn't matter, but the number of photoelectrons ejected per second from the surface will double. That's the only thing that will change. So B and C are correct, but A and E are wrong. So D is the correct answer. Both B and C can happen. Next, focus on concept question 07 says the drawing shows the results of a photoelectric experiment that was performed on a certain metal. The maximum kinetic energy, Ke max, of the ejected photoelectrons is plotted along the ordinate, and the frequency of the incident light bulb is plotted along the we call it abscissa or abscissa, say abscissa, however you pronounce it. Determine the work function in joules of the metal. So the work function is the energy minus the HF, the energy of the photon minus the Ke maximum energy that is required to take it off. So, but the minimum energy is the work function that is just when you get to that minimum energy, you are going to take off and knock off an electron from that particular material. So in this case, for the work function at this point, kinetic energy is 0 because the photon is not moving yet. So just have HF for this. There's no kinetic energy to move. So the basics of it is when you shine light, you first of all knock out the electron and then give the electron some kinetic energy. So the energy you need to knock out the electron before you give the electron kinetic energy is the work function. So that's just HF. So you use 6.626. I'm using 6.63 times 10 to the power minus 34 for the constant here, the Planck's constant. Miriam, lower your voice, I'm in the meeting. And then multiplied by a frequency, which is 5.4 times 10 to the 14. Don't forget this times 10 to the 14 here. So we'll give you this answer right here. This answer is in joules. Okay, in joules. We'll make sure I put this here in joules. Okay. All right. So the next is does a photon, focus on concept question 09, does a photon, like a moving particle such as an electron, have a momentum? Yes, it has momentum, and the magnitude of the photon's momentum is h over lambda. There is another option that says h times lambda. That's the wrong option. H divided by lambda, okay? And the wavelength from this momentum is called Compton's wavelength. We know that. So chapter 29, problem 01 says the dissociation energy of a molecule is the energy required to break apart the molecule into its separate atoms. The dissociation energy for a particular molecule is 2 times 10 to the negative 18 joules. Suppose that this energy is provided by a single photon. Determine the wavelength, frequency, and in what region in the electromagnetic spectrum does the photon lie. So the first part, Ht over lambda is energy. So lambda is Ht over energy. 6.63 times C over energy, we get our lambda. And then frequency is speed over lambda. So we get speed of light from the electromagnetic spectrum. From there, we get the frequency. And then you can also use frequency is energy over h. If you like, you get the same answer. So the wavelength and frequency shows value from the figure to 24.9, the text. You can compare your value of the wavelength. You can tell the range that it falls in the ultraviolet region of the range. Chapter 29, problem 03 says, light with a frequency 3.63 times 10 to the 15 hertz strikes a metal surface and ejects electrons that have a maximum kinetic energy of 6.3 electron volts. What is the work function of the metal? So work function is HF, like we said, so just H times F. So we'll calculate H times F to get the photon energy, but we are given a maximum kinetic energy. So the H and the F will give us the photon energy, and then we'll convert to electron volts. And then we have to use HF minus kinetic energy max to get the basic energy for the work function. So this is the difference between this problem and the previous one. So for this problem, when you get the photon energy, you subtract the kinetic energy, the maximum kinetic energy from the photon energy to get the work function. So a photon of red light, chapter 29, problem 16, the wavelength of red light is given and a ping pong of ball of mass that is given. They have the same momentum, so you're asked to find the speed of the ball. So for photon, calculating the momentum is h over lambda, and for a ball, calculating the momentum is mass times velocity. So we know they have the same momentum. We're asked to find the velocity of the ball. So it will be h over lambda divided by mass. That will give us the velocity of the ball since they have the same momentum. H over lambda for photon equals mv for ball. From there, we'll calculate v of ball. H is Planck's constant, lambda is given, and the mass is given for the ball. So we get our speed of the ball there. So focus on concept question 04. It says, let me see, hope I didn't, okay, I didn't miss anything here. Use the Bohr model to calculate the wavelength of the photon emitted when the electron in a hydrogen atom falls from n equals 4 to n equals 3 level. So the end state energy of energy level for a hydrogen atom is given by this, where Z is the atomic number, which is 1 for hydrogen. So from 4, put n to be 4. So 13.6 times 1 squared over 4 squared, 13.6 over 16 negative. So do that for 3 also, you get this answer. Z is still 1, and then the change in energy is the difference. E4 minus E3 becomes a positive answer. Negative, negative makes plus. Then you get your del E to be hc over lambda. From here, we get lambda to be hc over del E. And then in electron volts, hc is already 1240. Divided by delta E, you get your answer in nanometers. Okay. So if you like, you can convert this electron volt back to joules and then use everything here, Planck's constant, C meters per second, and joules, you get the same answer in nanometers. Okay. Chapter 30, problem 01 says the nucleus of the hydrogen atom has a radius of about 1.1 times 10 to the negative 15 meters. The electron is at a distance of about 5.29 times 10 to the power minus 11 meters from the nucleus. Assuming the hydrogen atom is a sphere with a radius of 5.29 times 10 to the power minus 11 meters, find the volume of the atom, the volume of the nucleus, and the percentage of the volume of the atom that is occupied by the nucleus. So volume of atom is 4 over 3 pi r cubed. That's the volume of a sphere, but you're using the radius of the atom, which is given. And then volume of the nucleus is 4 over 3 pi r cubed, but the radius of the nucleus, you get that. And then you just get the ratio, volume of nucleus divided by volume of atom times 100%. And you get 9 times 10 to the power negative 13%. Very, very, very little. The nucleus occupies a tiny space compared to the atom, but the nucleus has the mass of the atom. What a wonder. And then chapter 30, problem 11, find the energy in joules of the photon that is emitted when the electron in the hydrogen atom undergoes a transition from the n equals 4 energy level to produce a line in the Paschen series. So this is how we get the lambda in the Paschen series with this formula. Okay, so we use this constant 2 pi squared mk squared e over h cubed c to be this value, and z is equals 1 for hydrogen. So we put this value, we are going from what is it called? From 3 to 4. So we have 1 over 3 squared, is that okay? Minus 1 over 4 squared. Because when you transit, when you emit a photon, it means you are going down from 4 level to your 3rd level. So 1 over 3 squared minus 1 over 4 squared. And then from here, we'll get our lambda. So, and then we'll say this photon energy is after getting the lambda, HT over lambda give us the energy. So we've gotten the energy of that. So first of all is to get the lambda corresponding to that transition in the past chain series, and then use the lambda to get the energy. So that concludes the homework for this 29 and 30. I'll see you guys next week. You guys have a good one.